Hello and welcome to our video on D-Latches. Alright, D-Latches are an upgraded version of an SR latch. Here we see our original SR latch, but we know that with an SR latch we have an issue. When S or R are both 0, 0 or both 1, 1, we have a problem that creates some type of issue with our code. Whenever we run through our circuit, this creates a latch or creates an unsafe state. To remove that, we can notice a very cool thing. The only things we care about are when S is 0 and R is 1, or when S is 1 and R is 0. And there's no other combination of these two states, which means that these two are always inverse of each other. With the inverses, we can do something very cool. If we keep our enable but remove this part of our code, this part of our circuit, we can see that if we have a value D, this goes into our same AND gate, the enable. Here, keep the same structure with the AND gate and the enable, because a D-latch doesn't remove our need for an enable. A D-latch still has the same purpose. An enable will still allow us to write or allow us to not write. What we can do here is simply put a NOT gate. And a NOT gate flips the initial input. So if D, our first input, is going to be 1, this will be 0. And if D is going to be 0, this will be 1. Which means that we've removed all of the unsafe states from our SR latch immediately. Our SRD latch will always have a correct input coming in. It'll either be a 1 and a 0 or a 0 and a 1. And if we look at it, we can still see our SR latch right here. It's still part of the same circuit. We're adding things here to remove the issues we had. So let's run through what an example would be. Firstly, if enable is 0, nothing happens. None of this matters. We don't really care, because if enable is 0, nothing will move forward. It'll just stop right here. Now, say enable is 1. We can just assume enable is 1 for these two states. What happens is, what if we put D as 1? If D is 1 and enable is 1, that means we're going to get a 1 right here. And if D is 1 here, it'll be 0 here, and we'll get a 0 right here. Now we can walk through our code, same way as before, a 1 and a 0. We can guess that we're going to get a 1 here, bring the 1 down, we have a 1 and a 0, give us a 0, 0 and a 1, give us a 0, this 0, and this would be finally 1. Oh, comes back. A 1 and a 1 is 0. Perfect. There we go. We used this D input. If you remember, this was our R, and this was our S. So when R was 0, or R is 1, we get output of 0. Exactly what we had for an SR latch. And when simply by adding this small fix in the front with this NOT gate, we removed a lot of issues. So let's write that. When D is equal to 1, our Q is equal to 0, and our Q naught is equal to 1. This state here can be considered our reset. Now we can try the next step, D, 0. When D is equal to 0, let me erase this first, and then we can go through what changes in that option. If D is 0, that means coming through here we have a 0, and if a 0 here becomes a 1, and coming through here we have a 1. Now, there's two options. Either we can run through our code like we normally do, or run through our circuit like we normally do, go through the entire process, or we can take a look at this and go, hey, I have a truth table for exactly what this does. If S is 1 and R is 0, I know exactly what the outcome of that is going to be. And I know if S is 1, my Q will be 1, and my Q naught will be 0. Simple. That means that with this, we know Q is 1 and Q naught is 0, means this is our set state. Now we've removed the problem with an SR latch and created a new latch called a D-Latch. And this D-Latch can be used to store 1 bit of data like we talked about before. D-latches can be added on with multiplexers and decoders, and essentially with this very simple now that you understand it, with this one circuit, we can create an entire memory management system. We can put data into places, we can reset data, and we can use this to create and start building an actual computer. Thank you so much.